Have you ever wondered what lies above us in the sky? It's a question that has intrigued humanity for centuries. As we stand on the ground looking up, we're actually staring at the bottommost layer of an incredibly complex and fascinating system. This system, known as our atmosphere, is made up of several distinct layers, each with its own unique characteristics and functions. These layers, like chapters in a book, tell the story of our planet's interaction with space. They range from the troposphere, closest to us, where our weather occurs, to the stratosphere, home to the protective ozone layer. We'll also explore the mesosphere, known for its meteor showers, and the uppermost layers, the thermosphere, ionosphere, and exosphere, where the boundary of space begins. As we delve into these layers, we'll uncover the secrets they hold and the crucial roles they play in our survival. So, join us as we journey upwards from the ground to the edge of space. Starting at the surface, we first encounter the troposphere. This is the layer of our atmosphere where life as we know it exists, extending up to about 7 miles high at the poles and approximately 12 miles high at the equator. It's composed mainly of nitrogen and oxygen, with traces of argon, carbon dioxide, and other gases. This is where the magic of weather takes place. From gentle breezes to raging storms, all weather phenomena occur within the troposphere. It's also where airplanes cruise, taking advantage of the stable conditions. The temperature in this layer decreases as we go higher, a phenomenon known as the lapse rate. This drop in temperature is due to the thinning of the atmosphere with increasing altitude, meaning there's less heat being absorbed from the Earth. At the pinnacle of the troposphere, we find the tropopause, a boundary layer that separates it from the next atmospheric layer. Next, we ascend into the protective blanket of the stratosphere. Above the tropopause, we find the stratosphere. A realm of contrast and protection, the stratosphere sits quietly above our weather-filled troposphere, extending from about 6 to 30 miles up. Unlike the layer below it, the stratosphere experiences a temperature inversion, warming up as we ascend. This peculiar characteristic is due to the presence of a special component, the ozone layer. The ozone layer is a natural sunscreen, absorbing the majority of the sun's harmful ultraviolet radiation. Without it, life as we know it would be impossible. The ozone's absorption of UV rays is what causes the temperature inversion in the stratosphere. As the ozone soaks up the UV radiation, it warms the surrounding air, creating a protective barrier that shields our planet. This layer, so vital to our survival, is a silent guardian in the sky, a testament to the intricate balance of our planetary system. As we ascend further, the air grows colder in the mesosphere. Beyond the stratosphere lies the mesosphere. This is where we enter the realm of shooting stars, a zone often referred to as the meteor layer. The mesosphere, stretching from 50 to 85 kilometers above our heads, is a crucial part of our atmosphere. It's colder than any other layer, with temperatures plummeting as low as -90 degrees Celsius. One of the mesosphere's key roles is acting as a protective shield, burning up most meteors that dare to enter. As these space rocks hurtle towards Earth, they encounter the thickening atmosphere of the mesosphere, which causes them to heat up and disintegrate, often resulting in a spectacular light show for us on the ground. And let's not forget the mesmerizing phenomenon of noctilucent clouds. These are the highest clouds in our atmosphere, forming in the mesosphere and can be seen glowing faintly in the twilight sky. Our journey continues into the thermosphere, the gateway to space. Above the mesosphere, we encounter the thermosphere. This layer of our atmosphere is a realm of extremes, where temperatures can soar to over 2,000 degrees Celsius. But don't be fooled by these scorching numbers. If you were to venture here, you wouldn't feel the heat due to the sparse molecular density. The particles are so far apart that they rarely collide, making this layer practically a vacuum. The thermosphere is also home to the ionosphere, a sublayer that plays a crucial role in how we communicate. During the day, solar radiation ionizes the atoms in this layer, creating a sea of free electrons and positively charged ions. These charged particles have a knack for bouncing off radio waves, making long-distance communication possible. So, every time you tune into a radio station, take a moment to appreciate the ionosphere's role in bringing the airwaves to your ears. Our journey doesn't stop there. As we travel further, we reach the exosphere, the final frontier of our atmosphere. Here, the air is so thin it's almost non-existent. The molecules are so few and far between that they rarely, if ever, collide. Some of them, given a nudge of energy, can escape the Earth's gravitational pull entirely, venturing out into the vastness of space. The exosphere is our boundary to outer space. Satellites orbit within this layer, silently circling the Earth, relaying information back to us on the ground. It's here, in this remote and silent layer, that we truly realize how thin our planet's atmospheric skin really is. From the ground to the edge of space, we've journeyed through the layers of our atmosphere. Each layer with its unique characteristics plays a vital role in supporting life on Earth and facilitating our understanding and exploration of the universe around us. Our journey through the layers of the atmosphere concludes here. We've journeyed from the weather-rich troposphere, the lowest layer where weather phenomena occur, up to the protective stratosphere with its ozone layer that shields us from harmful solar radiation. We've ventured through the mesosphere, the layer that burns up meteors, creating shooting stars in their fiery demise. We've even reached the heights of the thermosphere, the ionosphere, and the exosphere, where the atmosphere kisses space and we find the northern and southern lights. Each layer plays a crucial role in maintaining the balance of life on Earth. They provide us with air to breathe, protect us from the harshness of space, and create the phenomena that inspire wonder and awe. It's up to us to protect and preserve our atmosphere, this delicate shield that is so vital to our existence. The next time you look up at the sky, remember the intricate layers above that protect us, give us weather, and connect us to the cosmos.